So all we're looking at for today is placing those special angles that we talked about before. So the 30, 45, 60, etc. Relate them to all the other angles within this grid, right? Because if you move past quadrant 1 here, you will get some symmetry. So you can use your knowledge of the previous ratios and the special angles to find any angle within this unit circle, okay? So we'll start with the very first one. If we call this here P1, the next arm over is about halfway between X and Y. So that means this angle here, if I'm looking at special angles, is probably going to be the 30-degree angle, right? The next one is 45, and 60, and so on and so forth. So I said I'm going to create the little triangle from P1. So we're looking at this area inside. We're not going to do that for all the triangles, but just for now so we can visualize it. Okay, so this is a right angle right here. And we said this being a unit circle, the radius is equal to 1. So for this one side, I'm going to write in a 1 for the hypotenuse. So if I'm just looking at this gray triangle, do I know a ratio for cos of 30 in value from before? Do we remember what that is? Cos of 30 is root 3 over 2. Okay? And from the triangle, we have cos of 30 as the adjacent, right? So the adjacent is what side? X or Y? The X. Okay, so I have the adjacent over my radius. In this case, we said being a unit circle is 1, right? So with these two together, if I equate them to each other, what do I get? I get root 3 over 2 is equal to x over 1. So what do I get for the x coordinate? If you solve, you cross multiply, right? So you get your root 3 times 1 and x over 2. What was it? Well, the x would be root 3 over 2, right? But yes, 2x is equal to root 3. Do we need a minute or okay? Yep.
When you cross multiply, how do you know which one goes on the top and which one goes on the bottom?
It doesn't matter which direction you choose, as long as you keep diagonal. So in this case, if you want the steps, it's root 3 times 1, right, is equal to 2x. And then to isolate for x, I divide both sides by 2. Okay? So that leaves me with root 3 over 2, right? But in this case, if I have my x over here, all I do is cross multiply and divide by the opposite of x. Okay? So we have root 3 over 2, and we'll do the same for the sign within that triangle. So I know the sine of 30 is 1 over 2, right? But within this triangle, sine of 30 is what coordinate?
Y.
The y coordinate over the same radius of 1, right? So once again, we're combining these two, and that gives us the equation 1 over 2 is y over 1. Again, cross multiply, and what do you get for y? Y is 1 over 2. Okay? So for that P1, all of this work for one little point, but from now on, we'll just remember everything together, so we don't have to do the calculations every time. Okay? So P1 in coordinates is going to be, the x value was root 3 over 2, and the y coordinate was 1 over 2, right? So we don't need to recalculate for the next angles. We know that for P2, we have what two values? if we're looking at 45 degrees. For 45, what is the cosine of 45? What is the sine of 45? Kalani? Root 2 over 2. Yeah, question, Aiken?
I just see like a pattern.
There is a pattern, yeah.
It goes like 1, 2, 3.
Yeah.
Step back up 1.
Yeah. That's right. If you look through the sine of 30, you're going from 1 to root 3, all over 2, and etc. Okay, so that would be for the 45 degree angle. And the next one is what value? 60. Okay, so that's my 60 for that. We'll have P3, and I know for that it switches, so my cosine is 1 over 2, cos of 60, and my sine is root 3 over 2. Okay. And now we're about to find out why this is so nifty. So if we move into quadrant 2, I'm going to reflect into the y-axis, right? We all remember transformations. Yep. So reflect into y. What happens there if I reflect into the y-axis? What coordinate stays the same and what coordinate changes and how does it change? Let's see, this one here is P4. Yep. Go ahead.
X becomes negative.
Yep.
And y is the same.
That's right. The x will be negative, so I have a negative 1 over 2 and root 3 over 2. Right? It's just a mirror image of point P3. And then we're going to go do the same for this angle. So we have a P5 that's negative root 2 over 2 and root 2 over 2. And in blue, we're going with P6. And Owen, what is this point?
It's going to be negative root 3 over 2.
Yep.
And 1 over 2.
And 1 over 2. Again, symmetrically, now we're going to reflect into quadrant 3. So we get a P7. So which coordinate will change here? From P6, do I keep x or y? Yep, they're both negative, so I keep the x and I change the y. Okay. 1 over 2, and continue, and we get a P8 of negative root 2 over 2, negative root 2 over 2. And finally, our P9 is negative 1/2, negative root 3 over 2. Okay, now I'll let you finish quadrant 4. And we'll go into a quick example. So let's say I want cos of 240. Which quadrant would I look in? 1, 2, 3. Yep. So I know it's in quadrant 3. And which coordinate am I going to use? There's two ways you can remember this. So any P point, any point that you're looking at, you know it's x, y. That's alphabetical. This is also alphabetical if I introduce my cos and sine, right? Or you just think back of your definitions of cos. So the cos is related to your adjacent, which is x, and the sine is your opposite, which is usually y, right? Because the angle is always nested at the center of the grid, okay? So the y will always be opposite to it, but the adjacent will be the x, yep.
So cos 240 would be P9.
Yep, it goes to P9, and it would be the x coordinate, right? That's what I was asking, okay? So I'll stick with x for now, but in terms of knowing which point it is, I need to break this down into my beta. So I know this is 180 plus 60. And now I know to use the value of 60, which is your P9, right? But you do need to show that the 240 breaks down into 180 and 60. So that would be negative 1/2. But you won't be given this chart on a test, so you do need to remember the basic rules, and you can always recreate it. The only rule that you should remember is that any point, right, for coordinate x, y, you can replace with your cosine of theta or sine of theta. And I guess we should also highlight in here the beta corresponding to this, the example that we just did. So that's the beta right there. Okay, and the full angle, the 240, if we write it as a theta, it would go all the way around. So a theta would start on the positive x-axis, and it would finish here. So this is my theta of 240. So given that I've used the coordinate negative 1/2, what would be sine of 240?
Negative root 3 over 2.
Negative root 3/2. That's right. Okay. And for extreme cases, in a way we already discussed this, and we'll just reiterate. You go with coordinates, you look at the points, the x and y intercepts of the unit circle. So x and y intercepts. So you're going to consider 0, 1, 0, negative 1, 1, 0, and negative 1, 0, right? And based on this, you can extract your sine of 90, sine of 180, 270, etc., right? So sine of 0, sine of 90, sine of 180, sine of 270, etc. Okay? And the same for cos. So it's a fun little circle to play with.